In this lesson, you will learn about using diagnostic commands and tools. In this lesson, you will explore the following topics: general diagnosis, debug flow, CPU and memory, firmware and hardware. After completing this section, you should be able to identify your network's normal behavior, monitor for abnormal behavior, such as traffic spikes, diagnose problems at the physical and network layers. By demonstrating competence in general diagnosis, you will be able to determine general information about the status of FortiGate. In order to define any problem, first you must know what your network's normal behavior is. In the graph shown on this slide, the range that indicates normal is shown in blue. What exactly is this blue line? It indicates the averages, our baseline. What is the thick black line? It's the current behavior. When the current behavior, black line, leaves the normal range, an abnormal event is happening. Normal is measured and defined in many ways. It can be performance, the expected CPU and memory utilization, bandwidth, and traffic volumes. But it can also be your network topology. Which devices are normally connected at each node? It is also behavior, traffic flow directions, which protocols are blocked or proxied, and the distribution of protocols and applications used during specific times of the day, week, or year. What is the first way to define what normal is for your network? Topology. Flows and other specifications of normal behavior are derived from topology. So, during troubleshooting, a network diagram is essential. If you create a ticket with Fortinet technical support, a network diagram should be the first thing you attach. Network diagrams sometimes combine the two types of diagrams: physical, logical. A physical diagram shows how cables, ports, and devices are connected between buildings and cabinets. A logical diagram shows relationships, usually at OSI layer 3, between virtual LANs, IP subnets, and routers. It can also show application protocols such as HTTP or DHCP. Another way to define normal is to know the average performance range. On an ongoing basis, collect data that shows normal usage. For example, if traffic processing is suddenly slow and your FortiGate CPU usage is 75%, what does that indicate? If CPU use is usually 60 to 69%, then 75% is probably still normal. But if normal is 12 to 15%, there may be a problem. Get data on both typical maximum and minimum for the time and date. That is, on a workday or holiday, how many bits per second should ingress or egress each interface in your network diagrams? How can we get information about the current status? First, let's look at CLI commands. You can use them through a local console, even if network issues make GUI access slow or impossible. A few commands provide system statuses. The Get System Status command provides most general-purpose information. Output shows model, serial number, firmware version, hostname, FortiGuard license status, system time, version of the FortiGuard antivirus, IPS, and IP reputation databases, and others. At the physical layer, troubleshooting analyzes which ports are plugged in, media capacity, and negotiated speed in duplex mode. At the data link layer, diagnostics often analyze how many frames are being dropped due to CRC errors or collisions. The output might vary depending on the model and NIC driver version. In all the cases, the output shows the physical MAC address, administrative status, and link status. If you suspect that there is an IP address conflict or that an IP has been assigned to the wrong device, you may need to look at the ARP table. The git system ARP command is used for that purpose. It shows the FortiGate interface, IP address, and associated MAC address. This command lists the information for all external devices connected to the same LAN segments where FortiGate is connected. FortiGate's own IP and MAC addresses are not included. Let's say that FortiGate can contact some hosts through port 1, but not others. Is the problem in the physical layer or the link layer? Neither. Connectivity has been proven with at least part of the network. Instead, you should check the network layer. To test this, as usual, start with ping and traceroute. The same commands exist for IPv6. Execute ping becomes execute ping 6, for example. Remember, location matters. Tests will be accurate only if you use the same path as the traffic that you are troubleshooting. To test from FortiGate to a FortiAnalyzer or FortiGuard, for example, use FortiGate's own execute ping and execute traceroute CLI commands. But to test the path through FortiGate, additionally use ping and tracert or traceroute from the endpoint, from the Windows, Linux, or Mac OS X computer, not only from the FortiGate CLI. Due to NAT and routing, you may need to specify a different ping source IP address. The default is the IP of the outgoing interface. If there is no response, verify that the target is configured to reply to ICMP echo requests. Good job! You now understand general diagnostics. Next, you'll learn about debug flow. After completing this section, you should be able to diagnose connecting problems using debug flow. If FortiGate is dropping packets, can a packet capture, sniffer, be used to determine the reason? To find the cause, you should use the debug packet flow. The debug flow shows, step by step, how the CPU is handling each packet. To use the debug flow, follow these steps. 1. Define a filter. 2. Enable debug output. 3. Start the trace. 4. Stop when you've finished. This is a sample of a debug flow output. Here we have captured the first packet of a TCP three-way handshake, the SYN packet. It shows the packet arriving to the FortiGate, indicating the source and destination IP addresses, port numbers, and incoming interface. The FortiGate creating a session, indicating the session ID. The route to the destination, indicating the next hop IP address and outgoing interface. The ID of the policy that matches and allows this traffic. How the source NAT is applied. This is the output for the SYNAC packet. It shows the packet arrival, indicating again the source and destination IP addresses, port numbers, and incoming interface. The ID of the existing session for this traffic. This number matches the ID of the session created during the SYN packet. How the destination NAT is applied. The route to the destination, indicating again the next hop IP address and outgoing interface. If the packet is dropped by FortiGate, this debug shows the reason for that action. This tool is useful for many other troubleshooting cases, including when you need to understand why a packet is taking a specific route, or why a specific NAT IP address is being applied. Good job! You now understand debug flow. Next, you'll learn about FortiGate CPU and memory diagnosis. After completing this section, you should be able to diagnose resource problems, such as high CPU or memory usage. Diagnose memory conserve mode. Diagnose fail open session mode. By demonstrating competence in these topics, you will be able to diagnose the most common CPU and memory problems. Not all problems are network connectivity failures. Sometimes there are resource problems in the devices. What else could cause latency? Once you have discarded problems with the physical media and bandwidth usage, you should check the FortiGate resources usage, CPU, and memory. If usage is high, there are tools that can determine which feature is consuming the most CPU. Additionally, you can troubleshoot faster if you know precisely which change, if any, corresponds with when the problem began. Let's begin by looking at the Get System Performance Status command. At the top, output shows that this FortiGate model has one CPU, CPU 0. This is followed by the RAM usage. At the bottom, output shows your network traffic. Next, let's examine the output for Diagnose sys top. It lists processes that use the most CPU or memory. Some common processes include IPS engine, scan unit D, and other inspection processes. Report D, FGFMD for FortiGuard and FortiManager connections. FortiCron for scheduling. Management processes. New CLI, MIG LOGD, CMDB, SSHD, and HTTPSD. To sort the list by highest CPU usage, press Shift-P. To sort by highest RAM usage, press Shift-M. The Diagnose sys top-summary command is slightly different than the Diagnose sys top command. The former is better for examining memory usage. Why? It collects all memory being used by a process and its child processes, including any memory that is shared between the processes. Let's compare the outputs of Diagnose sys top and Diagnose sys top-summary. They are different. In the Diagnose sys top output, child processes are listed individually. But in the Diagnose sys top-summary output, all child processes are listed together. The name is marked by an X, indicating how many times a process has forked. Because RAM for all forks, children, is added together into a total, Diagnose sys top-summary is better when you need to determine which feature to adjust in order to correct performance. What is forking? Forking is when the operating system makes multiple copies of a process in order to subdivide processing load or handle multiple similar tasks. If Diagnose sys top shows scan unit D running 3 times, Diagnose sys top-summary would show one entry with an X3, meaning it was forked 3 times. But Diagnose sys top-summary shows that all scan unit D processes are using 12 megabytes of RAM, while Diagnose sys top indicates that each scan unit D is using just under 2 megabytes. Why do they indicate different RAM usage? The 10 megabyte antivirus database isn't duplicated in RAM for each child process. It is loaded into shared memory, which isn't counted by Diagnose sys top. FortiOS doesn't allow different processes to communicate directly. So, if memory wasn't shared, then FortiOS would be required to load a copy of the antivirus database for each scan process. Each individual process would be using around 11 megabytes. Only 3 concurrent scans would require 33 megabytes. Performance would decrease. If the memory usage goes too high, the FortiGate may enter into memory conserve mode. While the FortiGate is in memory conserve mode, it takes some actions to prevent the memory usage from increasing, which could cause the system to become unstable and inaccessible. Memory conserve mode is never a desirable state, as it impacts the user traffic. 3 different configurable thresholds define when the FortiGate enters into and exits from conserve mode. If the memory usage goes above the percentage of total RAM defined as the red threshold, the FortiGate enters conserve mode. The actions that the device takes depend on the device configuration. If the memory usage keeps increasing, it might exceed the extreme threshold. While the memory usage is above this highest threshold, all new sessions are dropped. The third configuration setting is the green threshold. If the memory usage goes below this threshold, the FortiGate exits conserve mode. What actions does the FortiGate take to preserve memory while in conserve mode? FortiGate does not accept configuration changes, as they might increase the memory usage. FortiGate does not execute any quarantine action, including forwarding suspicious files to FortiSandbox. The Fail-Open setting under Config, IPS, Global controls how the IPS engine behaves during conserve mode. If the setting is enabled, packets are allowed without any IPS engine inspection. If the setting is disabled, packets that require IPS engine inspection are dropped. Remember that the IPS engine is used for all types of flow-based inspections. The IPS engine is also used when the FortiGate must identify the network application, regardless of the destination TCP/UDP port, for example, for application control. The AV-Fail-Open setting defines the action that is applied to any proxy-based inspected traffic, while the unit is in conserve mode, and as long as the memory usage does not exceed the extreme threshold. This setting also applies to flow-based AV inspection. 4 different actions can be configured. Idle drop drops all idle proxied sessions. Off. All new sessions with content scanning enabled are not passed. Pass. Default. All new sessions pass without inspection. One-shot. Similar to pass in that traffic passes without inspection. However, it will keep bypassing the AV proxy even after it leaves conserve mode. Administrators must either change this setting or restart the unit to restart the AV scanning. However, if the memory usage exceeds the extreme threshold, new sessions are always dropped, regardless of the FortiGate configuration. The Diagnose Hardware sysinfo conserve command is used to determine if a FortiGate device is currently in memory conserve mode. Another undesirable state for a FortiGate is the Fail-Open session mode. This mode kicks in not during a high memory situation, but when a proxy on the FortiGate runs out of available sockets to process more proxy-based inspected traffic. If AV-Fail-Open-Session is enabled, FortiGate will act according to the AV-Fail-Open setting. Otherwise, by default, it will block new sessions that require proxy-based inspection until new sockets become available. Good job! You now understand FortiGate CPU and memory diagnosis. Next, you'll learn about FortiGate firmware and hardware diagnosis. After completing this section, you should be able to format the flash memory, load a firmware image from the BIOS menu, run hardware tests, display crash log information. By demonstrating competence in these topics, you will be able to diagnose the most common firmware and hardware problems. From the FortiGate BIOS, administrators can execute some operations over the flash memory and the firmware images. To access the BIOS menu, you must reboot the device while connected to the console port. The booting process, at one point, shows the following message. Press any key to display configuration menu. While this prompt is displayed, press any key to interrupt the booting process and display the BIOS menu. From the BIOS menu, select F to format the flash memory. Doing this might be required if the firmware gets corrupted, or if the administrator wants to do a clean installation of new firmware. Keep in mind, though, that formatting the flash deletes any information stored on it, such as firmware images, configuration, and digital certificates. After reformatting the flash, you will need to install the firmware image from the BIOS. Follow these steps. 1. Run a TFTP server. 2. Configure the TFTP server with the folder where the firmware image file is stored. 3. Connect the PC Ethernet port to the FortiGate TFTP install interface. 4. Select Get Firmware Image from the BIOS menu. The interface assigned as the TFTP install interface depends on the model. However, and in most cases, it is either the Port 1 or internal interface. From the BIOS menu, select the option G to install a new firmware. The BIOS will ask for the IP address of the TFTP server, the FortiGate IP address. It must be in the same Class C subnet as the TFTP server, the name of the firmware image. If everything is OK, you should see a series of pound signs indicating that the device is downloading the image. The BIOS will then verify the integrity of the file and give you these three options. Save it as the default firmware, save it as the backup firmware, run the image without saving it. If the firmware is going to be used in production, select the first option. Save it as the default firmware. The last option, run the image without saving it, allows you to run and test firmware without overriding any existing firmware in the flash. Once you have finished the tests and are ready to roll back the change, you need to reboot the device, and the previously existing firmware will be used. Like with any other electronic device, damage to RAM can cause intermittent crashes. If you suspect hardware failure, you can run hardware tests. How do you run the hardware tests? It depends on the FortiGate model. For some FortiGate E-Series models, you can run the hardware tests directly from the FortiOS CLI. For other models, you must download special HQIP hardware testing images from the Fortinet Technical Support website. The steps for uploading the hardware test image are the same as the ones used for uploading a firmware image. You can run the hardware test image without saving it in the flash, so any existing firmware image won't be overwritten. For some E-Series models, the command Diagnose Hardware Test Suite All runs the hardware tests from FortiOS. The hardware tests require user interaction while running. Users can skip some of the steps, and some tests require connecting external devices, such as USB sticks or network cables to the FortiGate. Another area you may want to monitor, purely for diagnostics, is the crash logs. Crash logs are available through the CLI. Anytime a process is closed for any reason, the crash log records this as a crash. Most of the logs in the crash log are normal. For example, anytime the antivirus definitions package is updated, the scan unit process needs to close down in order to apply the new package. This is a normal shutdown. Some logs in the crash log might indicate problems. For that reason, crash logs are frequently requested by Fortinet technical support for troubleshooting purposes. This slide shows the command you have to use to get a crash log. Two commands can show information from the crash logs. Diagnose, debug, crash log history lists a summary of the processes that have crashed, how many crashes have happened, and the time of the last crash. Diagnose, debug, crash log read provides details about each crash in addition to other system events such as conserve mode entry and exit times. These are the entries generated in the crash logs when a FortiGate enters and exits memory conserve mode. Congratulations! You have completed the lesson. Now, you will review the objectives that you covered in this lesson. This lesson covered the following objectives. Identify your network's normal behavior. Monitor for abnormal behavior, such as traffic spikes. Diagnose problems at the physical and network layers. Diagnose connectivity problems using the debug flow. Diagnose resource problems, such as high CPU or memory usage. Diagnose memory conserve mode. Diagnose fail-open session mode. Format the flash memory. Load a firmware image from the BIOS menu. Run hardware tests. Display crash log information.